Dear friends, welcome to ARTos house. Today we have the chance to go to the second activity from the second phase of the program Continuum, which is co-funded by the European Union, more specifically from the Creative Europe program, and the Deputy Ministry of Culture here in Cyprus. And today we have the panel called Humans versus Earth. It's a mini conference, and we have some distinguished guests that will introduce them in a while. More particularly, the Human versus Earth. I would like to say that this panel aims to question the physical, mental, and emotional development of the post-human and their relationship with nature. It aims to understand how technological and environmental and societal transformations are reshaping our physical, mental, and emotional experience, particularly in how individuals perceive and interact in each other with nature. The event employs a cross-disciplinary approach, and we give a special emphasis in the cross-disciplinary approach, blending perspectives from fields such as physics, astronomy, computing, science, digital technology, artificial intelligence, and media art. By combining these disciplines, the panel examines the blurred boundaries between reality, virtuality, and artificiality that characterize our contemporary world. Today, I'm gonna present. One of the presenters will be Mr. George Jazas. He's an entrepreneur, mentor, speaker, gamer, and founder of Agion, which is a company that specializes in mixed reality training for many different fields. Then you have Dr. Orestis Pavlou, which is a researcher in astrophysics, cosmology, graph theory, galaxy evolution, space science and technology at the European University in Cyprus. And one of the reasons that we always want to include space in this is that we have to see also how many big things are happening outside little Earth, and so this will be an big inspiration for the rest of our actions. And then I'll present the human brain versus Earth, which is a more neuroscience approach to the field. And then, of course, we have Vladimir Turner, a Czech artist, which is an urban artist and activist, and that we host also samples of his works outside you can see. So without any further ado, I would like to invite Mr. George Jazas to come present.
Good afternoon, everyone. It's an absolute pleasure to be here with you today, discussing the intersection of humanity, technology, and nature. My presentation is Human versus Earth, Mixed Reality as a Mediator in the Post-Human Era. The focus of this talk is to explore how mixed reality, which is an emerging and transformative technology, is uniquely positioned to address the tension between technological progress and ecological sustainability. At a time when humanity is evolving beyond its traditional boundaries, shaped by technology and modernity, mixed reality offers a critical bridge to harmonize our aspirations with the needs of the planet. We're going to delve into challenges of the post-human era, the role of mixed reality in fostering clarity and connection, and how mixed reality can help us create a balanced and sustainable ecosystem. So, without any further ado, on one side of the technology coin, we see incredible technological advancements reshaping the way we live, the way we work, the way we interact. And for example, I cannot imagine how we would have survived the lockdowns during COVID without technology. At the same time, it gives us remote access and deep understanding, deep knowledge of everything that works around us. On the other side of the coin, everything comes at a cost, and we face mounting ecological challenges, such as environmental degradation, research depletion, and societal disconnect that demand urgent action. And this is where mixed reality enters the picture. But first, let's talk about what is mixed reality. I'm fairly certain that most of you, if not all of you, know what VR is, virtual reality. It's a headset that you wear on your head, and you completely immerse yourself in a fully digital environment, cutting yourself from the real world and interacting with digital objects through controllers. Then we have augmented reality, which you can use through mediums like a phone or a tablet to project into your real environment and digital item, much like IKEA's application to see if their couch works well with your current living room or if a table is at the right height. Mixed reality is the evolution of these technologies, creating a very balanced amalgamation between the real world and the digital world. It's an intersection of real and digital elements together at the same space, having the capacity to recognize movements, motions, and the real environment, combining everything into one. For example, I could pick up a digital ball with my hands, I could throw it, it would hit the ground, it would hit the wall, and I can pick it up back again. So this is what mixed reality is. Let's start with environmental degradation that we face. Climate change, deforestation, biodiversity loss are accelerating today at very alarming rates. Entire ecosystems are being disrupted completely by human activities, leading to consequences we are beginning to comprehend right now. The image on this screen illustrates the stark reality of what is going now. A landscape scarred by pollution, waste, neglect, and it's a sobering reminder of the true impact that we currently have on our home. Then moving on to resource depletion, which is one of the most pressing challenges of our time. Unsustainable extraction, consumption of natural resources like minerals and fossil fuels are pushing our planet to its very limits. Landscapes that were once rich with biodiversity are now barren. Reservoirs are drying up and ecosystems are collapsing under the weight of overuse. This crisis needs to be addressed immediately with action and rethinking how we can utilize and manage Earth's finite resources better. At the same time, it feels that the more connected we are, the more disconnected we seem to be. Societal disconnection is becoming increasingly evident. The rise of pervasive media and digital technologies has created a phenomenon that is known as media pollution. We are daily bombarded with fragmented, sensationalized, and biased information, making it very difficult to discern truth from manipulation. And this lack of clarity not only affects our decision-making, but also distances us from one another. In this context, we urgently need tools that can help us bridge these divides, tools that provide not just innovation for the sake of innovation, but also understanding of who we are, how we connect with each other, how we connect with nature. With this challenge in mind, let's see how mixed reality can help rebuild the connection between nature and between each other. And let's start with rebuilding our relationship with nature. One of the critical tasks is be able to study and preserve biodiversity. With mixed reality, we can enable scientists, educators, as well as policymakers to physically as well as virtually interact with endangered species, explore ecosystems that are otherwise completely inaccessible. Imagine being able to step into a coral reef on the brink of collapse or observe migration of birds on real time from your own home and interact with these phenomena in a way that is meaningful and dataful so that we can find a solution working together. This immersive experience provides invaluable insights into the complexity of biodiversity and the urgent need for its complete preservation. It also helps educating new generations in a more experiential way on how things work and how they are supposed to continue to work. Secondly, mixed reality helps foster empathy for environmental issues by making abstract problems tangible as well as emotionally relevant. For example, a child can witness the devastating effects of deforestation or coral sea pollution. These experiences are not just educational. They are designed in a way to evoke powerful emotional connections, turning passive observers into active advocates for change. One of the modules that we are currently running has to do with overmining and how it affects the entire ecosystem and how we could still mine without destroying everything around us. By combining these capabilities, mixed reality is not just a technology, it's a bridge to help us reconnect with the natural world in a meaningful way. Mixed reality can also help us rebuild our relationships with people. How? By making complex information accessible and interactive. Imagine kids experiencing chemistry, physics, history with their teacher in their classroom by igniting what is most crucial at that age, their curiosity. Imagine an astrophysicist or a physicist being able to examine a black hole in their physics class with their own hands and see how it interacts with everything around it. Imagine policymakers collaboratively visualizing climate change scenarios on how they are going to build a city and take informed decisions, including nature, during their decisions. It can also help us connect with each other by encouraging shared and meaningful interactions. In a world often divided by digital isolation, mixed reality enables people to work together collaboratively in same spaces that blend virtual and physical worlds. For example, a cultural organization can use mixed reality to bring diverse groups together to explore a shared heritage, or it can use mixed reality for business to create team building exercises so that you can build rapport with the personnel. Or you can use it as a family to experience something and you can teach children stuff and parents can learn as well. All in all, these applications of mixed reality can rebuild relationships by fostering understanding, empathy, and collaboration. Key ingredients for thriving communities in the post-human era. So how can we go about creating a new ecosystem in mixed reality? First and foremost, we can use it to create environmentally friendly, active collaboration across the globe. Imagine right now that in order to be able to collaborate with scientists around the world for physical experiments, we have to be in the same space. We have to take a flight, we have to book hotels, we have to overconsume. This can all be solved through mixed reality, where we can all be in the same space without actually physically being in the same space. And the digital space can accurately reflect what you are doing in a physical space. Secondly, mixed reality empowers sustainability by optimizing resource efficiency. Through simulations and real-time visualizations, we can track carbon footprints, we can design renewable energy system and optimize resource allocation, ensuring minimal waste while also ensuring maximum impact. With mixed reality, we're not just adapting to change, we are actively creating a new sustainable ecosystem that can bridge digital and physical worlds for a better future. One of the points that was mentioned in our discussion earlier is the ethics and the responsibility of technology. First, we must address the issue of bias in mixed reality. Algorithms, data that power mixed reality experience can unintentionally or not reflect societal biases and may mislead or marginalize certain groups. Developers and organizations must prioritize fairness and inclusivity to ensure that mixed reality can benefit everyone equally. Secondly, we need to be able to promote responsible development that serves both humanity and the planet in applications that foster relationship between each other without having money, greed, or societal biases as barriers in front of them. Conclusion. It's important to reflect on the central theme, the intersection of humanity, technology, and our planet. Mixed reality offers a transformative tool, not just for innovation, but for fostering empathy, bridging gaps, and addressing global challenges. As a knife, if you will, a tool, you can spread jam on your bread, or you can use it to kill someone. The responsibility of how we use it falls on us. It's a very powerful tool, and in Akol Ben's great words, with great power comes great responsibility. So it's on us on how to use it. Thank you very much for your time.
Thank you, George, for keeping the time limit as well, and your very to-the-point presentation. Also, I would like to thank everybody who is here because, you know, in Cyprus never rains, and when it rains and there is live streaming, people prefer to see it over the couch. So I appreciate a lot the fact that you are here. So now we go to call Orestes to come here for his presentation.
Hello, everyone. Just as Mr. Kendonis mentioned earlier, my presentation aims to give a bit of perspective. So basically the human perspective when we're trying to investigate the world around us, and specifically the world outside of Earth. It will be a mixed presentation of some historical overview, the modern view of the universe, and the main questions that I will be going through is beginning with how do humans investigate and understand the universe? So how do we view our world? Then moving on to the nature of space-time and our best understanding of what space-time is and what gravity is. And then at the end, I will show a brief showcase of what causes the largest and the brightest physical phenomena in the universe. But let's begin with a brief historical overview, where we have many ancient civilizations trying to interpret the world around them, the cosmos, just based on the observations of the stars and their movement in the night sky. I have a focus here on ancient Greece, but this is a common shared experience across all ancient civilizations like Mesopotamians, ancient Egypt, and across the whole of Earth. So for ancient Greece, I have a few examples here at the bottom you can see. The first attempts to interpret the movement of the stars and actual observations of astronomical objects is closely related to mythology and religion. Just as a couple of examples that I find interesting, on the bottom left of the presentation you can see the constellation of Orion. It's one of the most famous constellations in the night sky. It's characterized by the Orion's belt, the three stars you see around the middle of the human-shaped connection of the stars there, the constellation. And the Pleiades in front of it, the collection of a few blue stars. And in the night sky, just as in the daily sky, where the sun moves from east to west, the stars move from east to west as well. They rise from the east and set in the west. And just because the Pleiades were seen to move from east to west, Orion always came behind them. So the myth was created that Orion is a hunter just because you can shape the constellation as a man holding a shield or a bow. That's coming after the Pleiades. So it was thought in the legend that Zeus made the Pleiades into stars, and Orion is chasing them throughout the night sky endlessly. And also Pleiades, as another interesting fact, they are associated with rain. Why? Because these constellations, even now, are observed in the early night sky, usually between September and the end of winter. So they are associated with the presence of rain just because of its seasonal effect. And another example, one of the most famous, let's say, interactions between mythology and cosmology is the fact that we call our galaxy a galaxy, or our galaxy the Milky Way. The word galaxy comes from the word gala, which is milk in Greek. So the first interpretation of the bright band of stars you see in the night sky from the ancient Greeks was that it was milk from the breast of the goddess Hera when Hercules tried to breastfeed from her and she threw him away. And the milk spilled on the night sky and created the Milky Way, the galaxy. So this stuck with modern astrophysics until now that we also use the word galaxies. But also there was astronomical observations and attempts to measure the universe in antiquity and in ancient times. I just have a few examples here, like Democritus and Aristotle, who tried to, they theorized, but it was kind of an accurate theorization of interpreting the galaxy, the Milky Way, that is a collection of many faint stars. And other examples like Aristarchus of Samos and Eratosthenes include measurements, actual mathematical measurements of, for the former, the estimate of the distances between the ratio between Earth, Sun, and Moon. And for Eratosthenes, the estimation of the circumference of the Earth, which was the first recorded estimation with 2% error, actually it's a 98% accuracy. And it was just made by placing two shadows at two different points. And then Ptolemy collected many data and observations of stars and tried to interpret them as circles within circles. But the more classical view we have when the invention of the telescope happened, with Galileo Galilei being the first one to determine that the Milky Way that we observe in the night sky is actually very far from Earth, and it's made up of faint stars. And then we have the effects of this moving into philosophy as well. We see the philosopher Immanuel Kant, who theorized that these faint stars in the night sky, you can see the elongated and faint stars in the image there, that's a recent image from James Webb Space Telescope, that they are island universes. So you see how philosophy is also plays a role in our interpretation. The modern discoveries, I won't go through all of the discoveries here, but the highlights here is that it was not until 1923, so it was actually 101 years ago, when Edwin Hubble made the first, was the first to determine observationally that the Andromeda galaxy is a separate galaxy. That was the first galaxy that was ever determined to be something different, that's something outside the Milky Way. So the concept of many different galaxies was confirmed. And then a few years later, he made the observation that galaxies are moving away from each other and the universe is expanding. And if you extrapolate that to reversing time, then we have the first idea of the Big Bang. So the common point tracing back all of the movement of the galaxies. Now we know that there are hundreds of billions to trillions of galaxies in the universe. And this estimate can be interpreted as space-time, says that the space-time can be interpreted as a sea of galaxies. This is just a recent image from the James Webb Space Telescope of a very small part of the sky showing thousands of galaxies being detected. This is how it's extrapolated that there exist hundreds of billions or trillions of galaxies. But with our understanding of the universe, it's a very tricky thing to actually perform actual science or get lost in the meaning. I have two quotes here from Carl Sagan, who said, "Somewhere something incredible is waiting to be known." This is very inspiring as a quote. And then the kind of the reverse from Neil deGrasse Tyson, who said, "The universe is now under no obligation to make sense to you." So no matter how hard you try, if you don't have the tools, you lack the interpretive power. How do we measure the cosmos? How do we measure the universe? The tools we use, the measurements we use for 90 to 95%, maybe even more, for all astrophysical phenomena is light. The first one here, electromagnetic spectrum, is different types of light or radiation, and this is the way we interpret the universe outside Earth. Recently, in the past decade or so, we also have the rise of gravitational waves. And then previously we have the rise of attempts of neutrinos, neutrino astronomy and cosmic rays. I will focus on the first two, especially on the first one here. And what is light? How do we interpret the cosmos? We cannot have a complete idea of what we are doing if we don't understand the methods, the tools, and the measurements, the units of measurements we're taking. So light is made up of very different, it's a spectrum, it's made up of very different frequencies, wavelengths, and energies. You see on the left-hand side here, the frequencies are very high or short wavelengths, so we have high energy in gamma rays and X-rays. And on the other end of the spectrum, we have radio waves, which are very long wavelength light. And the light that humans can see, we can see from this image that it's a very, very small part of the entire electromagnetic spectrum, the visible light, the rainbow in the middle there. So we immediately come upon a limitation. But the greatest limitation, even in the modern era of astronomy, of observational astronomy, is that the atmosphere interacts with most of the light. So this is the entire spectrum, and as you can see from the image here, there is what's called the optical window. So the visible light we have evolved through our eyes to detect is just a small part of it that passes through the atmosphere, almost, but not entirely, without interacting with the atmosphere. And then we have the radio window, which is the very long wavelength light for which we need these giant dishes to detect the radio telescopes. But all other kinds of light are blocked by the atmosphere. I have an example here of a specific type of light, infrared light, that's beyond the red, if we take the continuum of visible light, where you can see in this animation, the image shown now is an infrared image, and then it's transitioning back to an optical image. Whereas the optical image you see now has many shadows in it, many places like the horse head on the right side there, or the flame nebula. This is astrophysical objects called nebulae, but this is basically gas and dust, including stars within them. But we would not know that the shadowy parts, the Horsehead Nebula and the Flame Nebula, the dark parts in the optical image host thousands of stars within them if we didn't have the image in the infrared, which shows the bright cores of this nebula behind the dark shapes, the dark dust. So there is the need for space telescopes. That is why modern astrophysics is performed mainly with observations from space, with telescopes from space, for all these different types of wavelengths, where we observe the same objects many times with many different telescopes, and we compare these observations, which give us indicators of different physics happening within this phenomena. For example, here I have the Whirlpool Galaxy, which is a galaxy that's being observed with all different types of light. And this is called multi-wavelength astronomy, which is only being performed for 10 or 20 years or so now, where we can actually see images beyond the central one, which is just based on visible light. So we can detect physical phenomena within them. Now, moving on a bit to the nature of gravity. Again, I have kind of a brief historical overview. Gravity was first theorized by Johannes Kepler in 1609 to be an attractive force of limited distance, radius, between objects. And then, of course, we have the revolution in the understanding of gravity coming from Isaac Newton's Principia Mathematica, which is a set of mathematical and mechanical laws that explain the movement of most planets in our solar system and the interaction between objects through gravity. But it wasn't until almost just a bit over a century ago where Einstein came along with his general relativity, his theory of general relativity in 1915, where he proposed that gravity is a feature of space-time. So space-time and gravity are linked. Within the past century or so, we've had many independent confirmations through different experiments of this theory, which basically says that gravity is the effect of the curvature of space-time. So if you can think of space-time like a sheet, you can see in the bottom left here like a green sheet that it's being deformed by the presence of a high mass object. So mass changes the shape of space-time. This creates wells or attractive spaces within space-time. That is basically the explanation for gravity that comes out of Einstein's understanding. And the best, briefest description of this was posed by John Wheeler, the kind of father of gravitation in 1973, who said that space-time tells matter how to move. So this sheet on the bottom left tells the objects how to move through space, whereas matter or mass tells space-time how to curve. So you see that the two are inextricably linked. And I have a couple of examples here of very recent detections and discoveries, like the gravitational waves that were first discovered in 2015 and reported in early 2016, which are ripples in space-time. So if we can imagine space-time like a two-dimensional sheet, which is space-time is three-dimensional, but we can simplify it as a two-dimensional sheet, then the interaction and the violent gravitational interactions of two very massive objects, in this example, two black holes or two neutron stars, you can see on the animation on the bottom right, create ripples as if in a pond. So these are gravitational anomalies, let's say, that are traveling at the speed of light, and we have detected them, confirmed them in 2015. And then last year was the discovery of the first proposal of the gravitational wave background, like a background noise within this space-time sheet of vibrations happening from different random gravitational events and phenomena. Now, gravity also shapes the universe. So the shapes we observe out there are created by gravity. Why is that? Because compared to all other forces, at large scales, gravity dominates. So I have a list of things here. Just briefly, we see that when dust and gas are squeezed together at the same place, they ignite to form stars around them. Rocks and dust and gas collide to create planets. These stars and planets dictate how comets and asteroids move around them. And then we have the end of the life of the stars. The giant stars end their lives explosively as supernovae, as we'll see in a bit. And then we have more exotic objects like black holes being formed at the end of the life of a star, or supermassive black holes at the centers of large galaxies. And galaxies themselves are formed, are shaped by gravity. And then they interact with each other and they form larger galaxies, they merge. Just briefly here, we have so far detected more than 5,000 planets and confirmed them outside our solar system. These are called exoplanets. Most of them are giant balls of gas and or giant rocks. This is kind of a observational bias, because if they weren't giant, they wouldn't have the effect big enough to detect them with our instruments. But about 4% of what we detect are the size of the Earth, around the size of the Earth, and either much lower than 1% of them, so like a handful of them, have been confirmed to include liquid water on them. So it's very, very rare. Then we have gravity shaping stars into many different types, depending on their mass and their energy. And then we see that gravity also dictates, and the mass of a star, which creates this gravity, dictates how the life of the star ends. For smaller stars like our sun on the top there, we don't have any violent explosions, but for very large stars, massive stars, they end their life explosively as supernovae, and the largest of them leave behind black holes. As I mentioned earlier, I've already shown an image of these. These are called nebulae. These basically populate the spaces between the stars. This is dust and gas, giant clouds of dust and gas, where many of them are thought to be stellar nurseries. So basically giving birth to stars, because it's a lot of dust, a lot of gas packed closely together. And through the power of space telescopes, like the James Webb Space Telescope, this is an image, I think, from last year, we have now the power to detect these large dust clouds and gas clouds within other galaxies. This is what you see here. The red and orange parts are these nebulae being connected together. And this would not be possible if we observed from the Earth, because the infrared light interacts with the atmosphere. And just a note for the more exotic objects, the black holes. Black holes that come from the end of the life of a large star are called stellar black holes. They are a few times the size of the mass of our sun. But on the other end, we have supermassive black holes being present and confirmed to be at the center of large galaxies. These giant beasts can range from masses from millions to billions of times the mass of our sun. They form over billions of years of consuming material and everything around them. And in 2019, you see the animation in the center is made up of the images that were actual detections, the first ever images, direct images created from a black hole. The black hole is not the bright part, it's the dark spot in the center there. The bright part is the material being consumed by the black hole, being heated. And when we have these types of black holes that heat material and then consume them inside of them, they are called active galactic nuclei. These objects are swallowing huge amounts of gas and dust around them, and they eject energy through light in highly energetic jets. And the brightest of them, the most energetic objects in the universe, are called quasars. These are actual galaxies with supermassive black holes being active in their center, emitting huge amounts of radiation. The first three images you see here at the bottom are actual real observations and images. The second image is actually the brightest quasar, the brightest galaxy in the nearby universe. And the third one is visible image, an observational image in the visible part of the spectrum from the galaxy that we have the first observation, M87, the galaxy that we have the first ever observation of its supermassive black hole. And lastly, we have gravity shaping, dictating the shape of different galaxies. So we classify galaxies based on how we observe them to be, to look, which is dictated by gravity and the interactions of the stuff within them. But let's look here. I think it's more interesting to show an animation of how galaxies, the largest things in the universe, interact with each other. And this is a combination of simulations using supercomputers. This is a simulation now of the galaxies, interpolated and juxtaposed, as you see here, with actual real images. And as you see, we have the simulation moving forward. The galaxies come closer and closer together, and they start interacting gravitationally to form these irregular, these strange shapes. These are two galaxies colliding, and you see actual images being shown throughout the entire process. You see here an irregular shape, but this is actually two galaxies dancing based on gravity. And they finally, slowly, over millions or billions of years, they merge into one giant beast of a galaxy. And you see how all of these strange shapes of galaxies can be interpreted by different viewing angles, and just by using these simulations to estimate how they interact with each other through gravity. So this is the final slide. I leave you the quote, a very famous quote from Carl Sagan, who said that the cosmos is within us. We are made of star stuff, so we are a way for the universe to know itself. Thank you very much.
As you see, that was a very nice blend because the same way universe is working, and of course our sensors, our eyes cannot see what's up there. We need extra technology to see and interpret what is there. That's exactly what happens in the human brain, and actually the same laws that apply to the universe applies also in our body, and this is what we're going to explore now, hopefully. Okay. When we talk about humans, we basically talk about the human brain. In the old times, we could see the humans as an animal with some special skills. But now we become more of a brain. So that's why we want to focus in the brain activities and how our brain creates what we call culture, which is interventions in our nature. First of all, when we say about brain, we imagine something that looks like that. And if we connect all the neurons that is in our brain, we can go around the circumference of the Earth at least 2.5 times. You can understand how much wire we carry in this tool called brain in our head. Of course, when we're born, we come with a personality, we come with special behavior patterns and everything. But we develop our own skills along the way. This is happening through synapses that we'll show a bit later how it works. And actually, this brain produces light. It communicates with light between the synapses. Now, I put the bottom left into a square, because I'm going to come back to that later. This unique machine understands stories and believes before reasoning. So that means whenever we see, we interpret it through a story or through a belief, which is another story. Exactly the same way that the humans were trying to see stars and make a story out of that because they wanted to understand. We didn't evolve in that. Actually, our brain is still the same brain that it used to be that time, that needs to make a story to understand. Even the relativity theory from Einstein, it had to make a story to examine it. This happens with the scientists, it happens with in religion, in history, everything. Now, all these cables we have in our brain, somehow have to find some shortcuts. For example, if I want to learn how to ride a bicycle, I cannot inherit that skill. That means I have to, through trial and error, I try again and again, at some point I do the right corrections, and I know how to ride a bicycle. That means that our brain makes some connections, like this old telephone system that they had in the old days back in the 30s. And actually what you see here, you see the ones that they were doing the connection, doing synapses, and you have somebody who was supervising it, and there was a request from somebody who said, I want to talk to Dr. Orestes, I want to talk to Lisa, I want to talk to Matthias, or whatever. So it was doing the connection. So there was a need, and then there was a synapsis, and then there was an observation and a guidance by somebody else. That's exactly how the synapses are done. And what you see here actually is like getting a branch coming from the presynaptic cell, which is the desire, and then goes to another neuron and connects. Actually, it doesn't touch each other, it's near each other, and just the exchange particles and photons, so not just to create these shortcuts. Now, the strange thing about synapses is that if, for example, I call Dr. Artopoulos and tell him, you know, I want you to forget how to ride a bicycle, it's going to be a mission impossible. You cannot forget, you cannot bypass what you consider, you cannot erase a synapsis, at least without any serious injury or something. Only when you have another synapsis that will be much stronger and it will be another shortcut before that it can happen. Now, humans share a variety of behavioral characteristics all over the world, and this is because of biology, psychology, and shared culture evolution. The culture, when we say culture, we say, culture is something, it's arts, it's something that are the achievements of humanities, but actually culture are habits. And the habits, when they survive in time, then we call it culture. Now, these individual differences exist through genetics, upbringing, and the environment. Some universal behavioral traits are common across all human, and I'm going to go to that. So genetics is our DNA that we are born with. So, for example, I may be impatient. This is part of my characteristic. I have to fight to win that. The upbringing, whatever happens from the age from 0 to 7, it's very vital. That means this is the first time that we intervene into our evolution and stays forever. And then it's the environment. If you are born, for example, in Syria during war, it's a different environment you grow up. If you are born, for example, in New York, it's a different environment. So this they have a strong footprint in your evolution. So let's see now what are the common denominators of all brains. First of all, we are social. We have the social nature. We need to interact, and we have a tendency to pattern and to categorization. You choose a football team, I don't know, you have ideology, I'm a communist, I'm a capitalist, I belong to this political party, I'm a vegan, I'm a whatever. So we need to belong to a larger group, because through that we can secure this social nature of ours. And this is why the social media and all these negative things you mentioned before, it addresses that weakness. When you have needs, this is a weakness. At least if you know it, you have these needs, you know how to handle it. So they come and they tackle this one, this need, and that's why we're all hooked into the social media and to these square screens that we see them all the time. Emotional expression, it's very important. For example, here in Cyprus is a small place, small country that acts as a big country. There is, and we, through many reasons, we didn't learn how to express our emotions. That means one of our basic needs are not complete. And as you see here, we have also the desire for connection. So if your emotions are not expressed, the desire of connection, it comes to a false pattern, because by the time you don't express yourself who you are, what you want, then the connections could be not compatible, let's say. Curiosity and learning, and you imitate. It's like monkey sees, monkey does. This is not only for kids, it's also in corporations and everything. Giving the right example, of course. You say, yes, you can imitate it. That's the best way to get somebody to behave the same like others, let's say. But imitating, it's always, if imitation needs extra effort, it is not adopted. You go for the easy imitation. That's another reason why all these things happen to that. Use of tools, that's why we managed to create all these buildings and everything, because we are not like the birds that they do the same, they design the same home, the same nest all over the world. Every time we do our changes, we have our own, we change the design approach every time because we develop these tools. And creativity and innovation, this is part, believe it or not, is part of our nature. And we get very enthusiastic when you try to use creativity, even for art or anything else, and innovative. No matter if you are an artist, you say, okay, let's do something that has never been done before. If you are an engineer, let's solve this problem because it's not tackled before. And I don't have to compete with the rest of the world because nobody thought of that. So it's built in our nature as well. Now, desire for meaning and awareness of our mortality. You understand that humans pretty much know that they will die from the age of 5 or 6, even if they don't process it. It's the only animal, allow me to use the word animal for this case, that knows from quite early that it's going to die. And it's very difficult to process a journey that has an ending, and then you try to make a meaning of that. It's like I want to buy a car, and I save money all my life to buy this car. Then you say, oh, but this car, you're going to have it only for a week. You have to find a meaning, what I can achieve in 1 week with that car. So the meaning, of course, it's a very sensitive issue, and it's another weak part of our brain. That's why we need belief systems, no matter it's ideological, philosophical, religion and everything, because we need to hook on something, at least to have a meaning. And if we are lucky, we can evolve into that. Or if we are more lucky, we can get stuck to that and we are happier. Adaptability, of course, this is, you see people changing from one environment to the other one, and finally they adapt. That's why we survive. Ethical and moral reasoning. We'll explain how this works before, because it's more a la carte, this one here. And conflict and comparison. Conflict and comparison is built in us. So if you dream of a wonderful world that's going to be peaceful and things like that, I think you have to wait, I don't know how many more centuries to evolve more or have another intervention in our brains in order to secure that. Conflict is in our nature, and cooperation is in our nature. And it's these two, it's like a Taoistic approach, and we try to balance between two. And of course, above all, the mastermind of ourselves is ego. I don't have to explain much about that, because this is coming more to that. Now that I described what a human is, and now we know that human has no predators, let's see this graph, how the number of the population was raised so far, and we see how many people were until the 1750. We had the first industrial revolution. I'm going to skip the explanation of each revolution, what is included, but then the second industrial revolution, it moved a bit more. The third industrial revolution, that was between 50s and 1970, it was combined with the vaccines, so some natural weakness, because nature has a way to keep the balance. So it does it in an autopilot way. We break that system and say now we can live longer, and then went to the fourth industrial revolution. Of course, is biomechanics and all this internet and all these things that brought knowledge, shared knowledge that is accessible to everybody. So you see that the population is growing and growing in a very logarithmic approach. And then you see, okay, what is the problem? If we have a lot of people, there is plenty of space. That's fine, but it depends on the behavior of this species, if it's too much. And we go here, and we see that the projections about this is that if everybody will have a good life, then this curve will start going on a steady line and remain into that one. But what does it mean? It will be educated and have prosperity. What does it mean? Because you know, the more prosperous you are, the less rate growth you have in societies. This is an extra slide I put in here just to see, for example, like that gives, for example, in relation to China and India. You see, for example, India is propagating much more than China. That China had a very dominant, role in the international community, global community, economy and everything. But you see a rising star, which is India, and all this population now that is growing, they invest on a very high standard of education, especially technology, and they start investing on what China is losing, so they try to get the investments into India. And you see how the population now it works as an advantage to that. And of course, you see all this. You will have the presentation, you have see the details. Now, let's see the environmental impacts of that. If we have a good life, if you are somebody, what is a good life for you? Yes, I want to have a home, a warm home. In Cyprus, we would say we'd like to have a cool home. I would like to go to a restaurant once a week to eat, and of course we want to eat meat, and so a lot of products, they need more animals, so it's okay. The most value for money is cows in order to have beef, because it's more massive and you can get more out of that. So we need more space, and usually we start cutting the trees to create more farms in order to satisfy the demand. So you see how the deforestation is going down. We realize now that if in Amazon we lose that forest there, we have huge impact in the rest of the world. So the rest of the world, I said to Brazil, hey, you know what? Because we are in danger on that, we can help you to find some other ways. And they said, okay, instead of taking the forest from left to right and wipe it off, we go into patches. We go in the forest, have one patch there, have it there, and then another patch. So that's why you see it started going, it was minimized, but now the demand is still a lot. So it's still going up again. So deforestation is a big impact because we know so little about plants and how, what is their role in nature and the weather as well. Okay, and now you see, for example, this is a very good slide because it shows how the biodiversity health is impacted when we try to say we can put more green, have more grass, it can still be green so the cows can eat and you can produce all this food for the people, and nobody's going to be hungry, they're going to have all the protein they want. But actually we shrink the biodiversity so much that it becomes as a boomerang to us. A lot of wild animals that they play a very important role in balancing the environment are gone. And then you see, okay, how you can produce, you can save biodiversity, reduce consumption. Okay, this is another culture we need to develop, and how the brain will deal with that. So we have all these elements here that you can see how we can protect this. Economic impacts, you can see that also in the presentation just to save some time. But all these things now, we come to a very crucial point now that we start having clashes all over the world. Because we pass a season of fighting, comes as a waves. Every 70 to 100 years, we have global clashes in order to redesign frontiers and everything. So we have resources competition, because energy is a key issue. So everybody's trying to get the energy from each other. Geopolitical tension, migration, and increase inequality. That's we will have the tendency of new revolutions, whatever revolution means. Now, a solution to mitigate these tragedies is, of course, to have family planning and educational initiatives. On that, we need a lot of work on that. Sustainable development goals, we started, but we are too far away from that. Technological innovations in agriculture and energy. This is something we do to invest a lot in technology and agriculture, which is good. And then international collaboration on resources management. This is it's just a dream, I think. It's a hope, and only a miracle could save us, because this always involves military action. And as you see here, there is like the conflicts now around the world. If you see the one with the black color, you see that it's expanding, and it's in our region. And of course, now we are in the borders reshaping, and I hope this will end up soon, because I don't see any future on that. Now, people say, all right, let's see the future outlook. Projected regional growth, hotspots, and then we have to wonder who has controls on the data for this. And then the role of global governance, which is a big desire for this, since they want a global government. Okay, you know, when people have all the power in their hands, how they behave. And need for balanced growth and environmental preservations. who defines that at the end? So all these things are not in our control. So the question here is population growth is both a driver of development and a source of challenges? Do effective policies and international cooperation exist in real sustainable way? Can technology outpace growth? And this is something we have to see, because technology can help growth, but at the same time it's pulling things down. So we have to choose the right technologies. What you present before is that it has an impact. It can measure, for example, in real terms, what is the impact of that. You can see what is the benefit of what money you put into that. And how can global equality be achieved? Okay, if humans beat Earth at the end, Earth doesn't have to worry about that, because the same substances are there already. It went through this phase 5 times so far in history, and it started again. It's no problem. All the elements, all the ingredients, all the basic elements are there. It's going to be fire, water, and everything will restart again, no problem. And now we go back to this one here. I'm not going to show this one here. And go back to these characteristics here. Social, nature, and tendency of patterns. In order to change our culture on that, we have to create personal time. This is a big issue. How to create personal time and avoid authorizing belief systems to manage your beliefs. Sometimes we believe in something, and then because there is another system that has more or less, it looks like it's the same belief, we adopted that, and then we follow what they say. We have to have our own critical thinking on that, and this is a learning process we have to do. Because when we rationalize this, we can avoid these kind of things. Express your emotion and connect with yourself and belong/connect to many categories. So in order to have the emotional expression and desire for connection, don't connect to one category. Try to connect to as many categories as possible, because you learn and you can see and you develop a new skill that the brain can understand and see this from many different perspectives, exactly the same way that we see the universe through different types of telescopes, and we get more information, and it's more credible information. A piece is also for the curiosity and learning. I would say that learn in a cross-disciplinary manner and be authentic. This is something that we don't know how to do it. And when we see on somebody else, we say, oh, that's really good, and then let's try to see how we can do it. But being authentic is not something that comes by nature. You have to develop it as well. And use tools for creativity and innovation. Of course, you have to develop or adopt independent new tools. It has to be independent, because the tools that technology gives us now, it gets us into a system that we give for free all our patterns, and this collection of patterns understand all the weaknesses of the human body and its control. Now, for desire for meaning and awareness of mortality, religion, philosophical groups, revolutions, I put it to quote, etc., should be viewed with caution, because this is misuse of these elements could take us into very bad situations. Now, when it comes to ethical and moral reasoning, we do it more a la carte. For example, it's okay, for this case I have done it and I'm proud of it, and in another case I'm not doing it because somebody else did it and it was okay, nobody said anything to him. So we change our story. We have to have consistency on our pattern. And as far as the conflict and cooperation, politics and geopolitics cannot be managed. So in this case, we have to bring it to the low level, to the micro environment around us, and start applying it there, and hopefully this could be enlarged later. And for the ego, I think we have no other solution than to rethink and turn me into we, and then we can see ourselves into the we, and through that we can satisfy our needs. Thank you very much. And now I would like to call Mr. Vladimir Turner for his presentation. It's here.
May I ask you to turn off these lights because we are going to watch some movies, so it's better that there is like darkness, kind of. Thanks. And I will reduce the volume here. Okay. Hello, my name is Vladimir Turner. I'm an artist. I usually do art somehow connected with society, politics, environment. So it could be called political art or engaged art. And I will show you, the first thing I will show is a trailer for my upcoming feature movie, which is about the fact that the whole mankind died and I'm the only person left on Earth, but at the same time I'm the first person, so I'm the last man on Earth and the first man on Earth. Then I will talk later. For example, private property made this world the place we see it is, and technological progress and the race for innovation took us in this phase of climate catastrophe that we are in, and there's kind of no doubt about it. So any type of new technological progress is making this planet going to be more damaged than before. So in a sense of technological progress, I believe in progress. We need a progress in medicine, in sustainable technologies. Let's say, I think we should avoid as much technology as we can, because with each new invention, we will exploit the planet Earth more. We will produce more waste. We don't know how to recycle it. With each gadget, with each VR glasses we have seen in the first presentation, we will have more batteries that we don't know how to recycle, and we know that the resources are limited, and we are already at the border of worldwide climate wars. So that was the part where I was trying not to be pessimistic. And now, I wanted to play a movie as a background to this, so it's not so pessimistic. I will play it without sound. This is an excerpt from a movie which is called Modern Times, according to Charlie Chaplin and his film Modern Times. So this is me being a new age Charlie Chaplin. I will use it as a background for my non-pessimistic speech. So I really wanted to be kind of positive, but I don't know I don't know how to how to do it after these talks we had before. In my I've had another presentation yesterday here, so actually I will probably go back to that the only way how to not get mad in this world, seeing all what's happening, is to make art. So I usually choose some simple symbols. I do intervention art, political art, sometimes sculptures, sometimes videos, sometimes films. This is a movie where I chose as the object of the movie is a hoverboard, the thing you saw me as a performer being on, and you will see it again. So I usually choose some type of object which is a symbol of human stupidity and nonsense invention, which is a hoverboard, for example. And I play with these gadgets in some kind of satirical way to show the absurdity of the technological development. So in this film, it's a 20 minutes long film. As a performer, I'm in. You can see me in different roles. Sometimes those are family roles, working class roles. I'm a priest. I changed the persona, and I'm showing that the technology is not, for example, here being in the roles of working class, talking about the Industrial Revolution. I don't think like we kind of gained by Industrial Revolution. The rich gained by the Industrial Revolution. It's kind of nice that we have got 8 working hours a day, which kind of, it's better than slavery, but it's kind of close to slavery. So in each role in the movie, I show my different type of pessimism about the technological progress, actually. So now I'm aware of the fact that it looks like I'm some prehistorical medieval host here after your presentations. I was thinking about talking about the book Back to Earth by Bruno Latour, French author, which is really important to me because after seeing her presentations, I felt like I need to get back to Earth. So in this movie, you can see, let's switch a bit.
System change, not climate change. 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 System change, not climate change.
people smile a bit watching this movie. That's strange. I couldn't hear any laughs. So whenever I do a big project, I need quite a lot of technology, as you can see, and with bigger art project, it actually feels more alienated through to the art and the core of the subject I'm working on. So then, yesterday I realized after yesterday's presentation that it's nice to go small, not to go big. And I want to the last thing I will show. I would like to talk about the topic of micro adventure, which is a term used for type of adventure where you don't need money, you don't have big expectations, you don't need to travel around the world to see exotic countries, you don't have to spend too much energy, you don't need any special tools, you just explore your local area and you become connected with the local area and you kind of get to know yourself through the local area. Now I'm here, it's not my local area, I'm here for the last 3 days. Yesterday we had kind of intensive talks and Matthias told me about the green line in the next blocks. So I went there for a short walk today and it started to rain and it was great. I was in the rain and it actually felt like being in the middle of micro jungle. There are these terms like urban wilderness, new wilderness, these places where the nature is taking over because the mankind already forgot about these places. So usually sometimes there are brownfield around the cities which look like post-apocalyptic places. There are abandoned supermarkets, these type of places which we are going to expect in the future when there is no electricity and there is no need to have supermarkets so I kind of like these places. So I went for my micro adventure in the green area next to this house, and now I will totally get back to Earth, according to Bruno Latour, and go back to just being like a small child going around the house. So what you will see is my diary from today, which I edited 1 hour ago on my phone. That's the end of my presentation.
Now we can ask the presenters to sit here. Sunny, you can put the slide on that on there. a whole Pavel is looking at us from Brack. And so if there is any questions or anything to discuss, we can be more than happy to reply. Yes, and the microphone.
Yes.
Thanks for your talks. I've got a question for George. I totally believe that mixed reality offers a lot of solutions to many problems. I might be wrong, but so far I understood that every technical development that promised a lot of advantages usually failed by the rebound effects. Like let's take the development of cars. The engines become better, stronger, but in the end the cars don't really use less petrol because the car becomes much bigger and much more multifunctional. So the positive development of a better car engine actually leads to like more waste and more resources use and so on. So my question to you would be, what kind of rebound effect can you imagine that can happen to mixed reality?
Well, as a rebound effect of mixed reality, depending on how it's being developed and by who, it could be used as a tool to further disassociate humans from each other. This is the most dangerous path that I can imagine. There is actually a Black Mirror episode that comes to mind where soldiers are getting implanted with a neurotransmitting device that alters their perception of reality, seeking enemy combatant or hostiles as demons and or monsters, so they will be able to kill them without remorse. This is why I stressed out the use and utilization of mixed reality. It's a tool, and it's up to us of how we're going to use it. We can use it to effectively save someone from a cardiac arrest episode from 300,000 miles away, or it can be used for evil. It's up to us.
At the same time, mixed reality could have another advantage to compare to the other accessible technologies now, that, for example, they engage the body into that. And this is something that if the body is not engaged in the process of learning or having an experience, then it doesn't have the same impact in learning or in the experience. So, as I learned that from Elisa, sitting is the new smoking. So actually the fact that you can wear a device that you can proceed, engage your whole body into that is something that will have another value also to the human body. But as far as the leftovers of this technology, this is something that if we move into a degrowth approach. That means that we make machines last longer because we don't want to enter to 3 and 4 and 6 stages within a decade. That means that we can save money, and companies can make their profit still without investing again so fast into innovation. And we don't need to use all these raw materials from Earth. So I think the growth and move slower in technology, but invest in technology that engage more the human body. I think it's something we have a counterbalance on the bad effect that could possibly have. Something that I wanted to say on Orestes' presentation, because he mentioned that matter is controlled through gravity, through the ripple effects of the gravitational waves. This is true. It's something that we don't even understand here on planet Earth. We may even think that planet is not even a sphere sometimes, because what we see is how we conceive it. But actually the gravitational effects have this ripple effect. It can have an impact on our thinking pattern as well. And actually gravitation in planet Earth is changing according to the location. And we see also our hormone system being influenced by the changes of the gravitation. So there is a lot of new learning to see whatever happens in space, how our place is in the universe, how it's being impacted. It's the same way like the Amazon forest is deforested, and we all feel the impact here, for example, in a small country like Cyprus. The same thing can happen with phenomena in the universe, and keep in mind that matter is only 4%. The rest is, the other 96% is dark energy and dark matter that we still don't follow the laws of electromagnetics on that.
Just let me make a small comment on the previous comment by Mr. Kendonis. Actually, we can take that hormone effects, effects on hormones and the evolution of the human body through the role of gravity to that by investigating the other extreme. Like we have scientists now performing experiments in the International Space Station with almost zero gravity, where we see different growth in muscles. The muscles stop working and they atrophy and they have to retrain when they return to Earth. Bones get elongated. They have to exercise, I think, 2 or 3 hours a day just to keep the blood flowing in the regular rate, because our body has been has adapted completely to having 1 g of gravity, so the gravitational attraction of the Earth. So everything from the circulatory system that sends blood with higher pressure towards the top of our body compared to the bottom of our body is dependent on the fact that we are gravitationally bound from the moment we are born to the moment we die. So our whole physiology has to be rethought when we're thinking about traveling outside that small sliver of space we can survive in, which is just a thin, very thin layer on a ball, a rocky ball going around the star. This is the atmosphere.
I would like to comment on this because I'm working a lot with the gravity and how it influences the human body. And basically, what I'm trying to teach in what I'm doing in the Alexander technique is to train people how to really use the gravity. So, although gravity is pulling us down, the way we are evolved, it was against gravity, and this is what brought us in the standing position. And most of our problems, okay, we cannot live without the gravity, but at the same time, we really need to re-educate ourselves how to use gravity, because we take it for granted, and we are giving in to gravity. And although we evolved to stand up, basically
It's
we
like
forgot.
devolving
Yes.
Downwards again.
we forgot that,
giving into
okay,
gravity.
we need to use the gravity and really think up rather than giving in.
Exactly. If I can make a comment on this, the reason Homo erectus was so important as an evolutionary step is because it freed our hands, so we didn't need them for movement, and the opposable thumbs helped with building tools. And this,
The tool of the tools, according to
this is what
Aristotle.
helped us to evolve into societies, etc.
But I wanted to make a question to you, Mr. Orestes, because I'm aware that there is a critique about space, how you say, space, I don't know, investigation or exploitation and all this. And the critic, it says that so far we were unable to preserve planet Earth. And what do we need to go beyond it? Why do we need this knowledge?
Yes, I understand it feels a bit much to try and investigate the nature of black holes in other galaxies when we haven't solved our problems in our own neighborhood. There's wars going on, etc. There's famine everywhere. I mean, the reason of basic science and basic research is that it enables us to find solutions for our immediate environment through other things. So, for example, even the evolution of lasers was performed by evolving technologies to try and push the race to space. Even other examples, such as even environmental issues, were highlighted with a push from scientists all over the world in the 70s and 80s, when we started understanding other planets in our solar system. For example, Venus. Venus is the most extreme example of a greenhouse effect. So we have indicators that Venus is not always the way it is now, even though it is farther than the Sun than Mercury. It is much hotter. Why? Because it's surrounded entirely by gas. And this gas traps the light inside of it, exactly like we compared it with our CO and CO2 emissions that trap more light inside our atmosphere. And this is a runaway effect because it increases temperature, heat. It doesn't allow the growth of any water or ice. And this has another exponential runaway effect that it cannot reflect light, because ice, one of its functions on Earth, on the poles, as well as the desert in Sahara, let's say, is that it reflects light back into space. If you don't do that, you absorb the light and keep it inside. It just bounces around in the atmosphere, and you have huge temperatures. And this was one of the examples that actually, I think it was Carl Sagan that I presented, testified in the Congress at the US in the 1980s, trying to give an extreme example of why we should investigate, at least, the climate change. So by investigating space, we see different environments, we understand different physics. It's not only to create the tools to escape this planet or to understand our place in the cosmos. By understanding the basics of nature, which is sometimes hidden from us, like the example with the atmosphere I showed, we understand the nature of things, where things can go wrong, where they can go right, and what's the best plan for moving forward for humans. And of course, it has many other offshoots into other sciences. Thank you.
I have one more question to George. Do you think the way mixed reality is used, it goes beyond the brain. I mean, the experience is also something we embody in quite enough way, like how the body participate in these experiences.
Mixed reality has the capacity. Mixed reality has the capacity to include the entirety of the body. Hence, some of the modules that we are using are used for physiotherapy, for Parkinson patients, and for breast cancer survivors. And we see that their attitude, whilst doing the exact same physiotherapy, is that their brain is engaged in a more joyful, playful, and serene way, in a way that they pass through their entirety of their physiotherapy without having the pain levels, the pain indicators, as much as the other focus group that does it without mixed reality. So mixed reality affects the brain and the body, and by utilizing it in a proper way, we can achieve so much more, in the sense that once the brain believes that something can be done, it will physiologically evolve to do it.
Yeah, okay, this is another question, because sometimes we have this faulty sensory appreciation as humans, but of course, if you include this in the design of the whole experience, I totally understand how it works. Okay.
Just a thought after Hilea's presentation. I was very much interested in what you said, that human is the only animal that is not being hunted or doesn't have any perpetrators, amongst other animals. Mm-hmm. And I was wondering, this is a case of the last centuries. Because in the beginning, before Homo erectus, or in the first years, he was hunted, right? He was by animals, so he was more an endangered species. Mm-hmm. And I was wondering if now that we are not in danger, we invent enemies, and we think that we are being hunted by other humans. So maybe that's why there's so much war and and pain amongst us. And I was wondering, what is the solution to this state of mind?
Yeah, this is a very good question, because the brain was developed to do two things: support movement and protect the body from potential dangers. Mm-hmm. So the brain, if you go down in the hypothalamus, there is a little gland there that is is what we call the ROM in a computer. So it's all the programming is there. So it's always in alert position, even if there is danger or not. It's standby mode. That means what? That means that if there is no threat, it becomes passive. But if you want to play with that need, you give him a threat. For example, I give you a little simple thing. You want to make an advertisement about toothpaste. And you say, all right, if you don't brush with your teeth with this toothpaste, these black little things will eat your teeth. So you engage a tiny little innocent fear on that, and then you automatically react to that. And then you hear there is a big robbery in Paphos, which is far away for a small country, far away from here. And then you say, okay, I'm going to lock my house today. So these little behaviors, because the body is always alert on that. Now, some people, they train themselves. They say, I do inhibition to anything that will engage my mind into any threat. So inhibition to these kind of things, it gives you more relaxed time. That means less cortisol. Cortisol is the hormone of stress. Cortisol that runs in the body. And this is the key issue. So the answer to that, I think, I would say, is that don't react immediately to any kind of stimuli that comes to you, that activates that open gate we have in our brain about...
Maybe don't listen to the news on TV.
But that's why you always give more attention to bad news. Because you are alert and you try to make sure that all the places or your gates are protected.
Yes.
You want to be proactive.
Thank you.
Also, I would like to comment on Vladimir's presentation that I found very powerful and really impressive, the way you found to communicate and to show your disagreement to whatever is going on against the planet Earth, and at the end of the day, against human. Maybe it's not human versus Earth at the end of the day, but
Humans versus humans.
yeah, Earth, if we go against the Earth will go against us at the end of the day. And if there are no other questions, maybe we can wrap up the event. I give the floor to Achilles.
Okay, that was just to wrap up, is that we heard from George that there is the bridge between passive technology communication and the body now is the mixed reality that is as, and to quote, dangerous like any other tool that exists on planet Earth, but the potential of using it right, it's much more, because it can engage the body into that and the experience. And actually, because I know for some of his projects that we don't have to expand on that, the body experience exactly the same condition as if it was running in the forest and doing all these activities, and they produce galactic acid in the muscles and everything just by experiencing that, because the body is engaged into that. Also from Orestes, we see historically how humans always are looking up and trying to make sense out of all these stars that are up there and try to make a story in order to explain it. And that's why this story was, up to a certain point, quite accurate, because they're trying to explain phenomena through storytelling. And then we see how galaxies and black holes, even he called it exotic, that gives another meaning when you say exotic. Black holes, it sounds like something nice. It's a very scary place to be. But we see that we can still walk and interact here on planet Earth, because some black holes interact with each other and send us the ripple waves here. And from the brain side, as a way to develop culture and behaviors on planet Earth, of course, we see that the story and the beliefs and all this, we analyze all these common characteristics that exist for everybody around the world, and we see our sensitive parts that we are open for any kind of misusage of our personality, our knowledge, and our entity in general. And of course, going to Vladimir's work with his authentic work and also his spirit of adventure, and I must admit that I like your selection of the 3 different videos. The one that is work in progress, that was showing being the last man, but at the same time, if you are the last one, you're also the first one. So it's a very good simulation of how we could experience if we are this kind of person, and then end up with this micro adventure that you work just 100 meters from here and you walk on this linear park, and you discover so many things. And I like the expression you said. I went as a kid that I wanted to play and explore, and actually that's this is a very good closing, because you forgot how to be kids and you forgot how to explore without having the responsibility to deliver something, but to explore about playing with that and get a new experience and learn something new. And this is something, of course, we are missing, and thank you for this experience, bringing that is right next to our doorstep. Thank you all for being here. Thank you for the people that they watch us through the live stream, and